This is example 10.2. Design a harmonic cam to satisfy the same motion demand as for example 10.1. In this case, I will show you how to calculate displacement, velocity, acceleration, Z of the harmonic motion, and how to use the XY scatter plot to draw SVA Z. We have amount of rise and return intervals here, and can rotation angle for rise and return interval here. Because we need to calculate velocity, acceleration, and Z, so we need to give a can rotation speed omega. We give it 16 RPM here. Let us see the rise interval first. The formula of harmonic motion is this. Here, we only use one harmonic curve to fit the rise motions. So we have can rotation angles are from 120 to 118. We see the formula of harmonic motion is a cosine function. The Excel cosine function returns the cosine of an angle given in radius. So we need to use the radius function to convert degree to the radius. For can rotation angle, we put the radial function here, equal sign, and reference B16 here. So we can convert degree to radius like this. Here we need to use beta, also must be radius. So put here radius function and here too. I put the formula of the displacement here. Equal signs L over 2 times 1 cosine minus cosine and pi. Here we can put pi here and times theta over beta. Beta is a can rotation angle required here, and enter. Let me see the formula. C1 and E7 must be fixed. So I give it dollar sign here and here. and then copy this formula to the other cells. Let us see the return interval. We have canned tension angles from 210 degrees to 316 degrees. And the formula of the return is this, equal L minus y of theta. So we put the formula here, L minus y of theta here. L again over 2 times 1 minus cosine pi times theta and over beta. Now this is for return interval, so you will use 115 here. Enter. So C1 is amount of the return, so it must be fixed. $sign here. And C12 is beta. It also must be fixed. Enter. So we copy this to other cells. It's not correct. Let me check it. L1 minus L1 2 times 1 cosine pi C. Oh, here is wrong, not correct, because I must reference a radius here. And again, $sign. It will get the right answers here. Now let us see the velocity, acceleration, and the drag. We have derivative of the rise interval like here. And the derivatives of the return interval here. We just look at the return interval. You can follow the same procedure to calculate velocity, acceleration, and the drag for the rise interval by yourself. I put V, A, J here and type the formula of velocity here. Velocity is equal to the first derivative times omega, and omega is in radius per second. So now we have 16 RPM, so we need to cover this into the radius per second. So equal sign 16 times pi over 16. we can get the kind of tension speed in radians per second. And type the formula here. We see it is miles pi times L over 2 times beta times sine pi times theta divided by beta and finally times omega here and enter. Let me check. Minus pi is correct times L divided by 2 beta times sine pi times theta divided by beta and times omega is correct. So let me see. C1 is fixed, E7 is fixed, and E2 is fixed. So I put dollar sign here, 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 and here to get the correct equation, and copy this formula into other cells. So I think it's not correct. Let me check what's happened. Oh, because we just write a return interval, so here is not correct. We need to change it to here and here. Again, dollar sign, here dollar sign, and enter again. Let me see again. Good, it's correct now. In the same way, I type the formula of acceleration here. And drag here. I think this value is not correct. Let me check what happened. Here, the kind of tension speed, the formula is type times pi, but it is not correct. It must be times 2 pi. Enter. So I check it again. It's correct now. Let me see the formula. The acceleration is equal to the second derivative times omega square. So I see L over 2 and pi over beta square, pi over beta square, and cosine pi theta over beta. Finally is omega square is correct. Let me check. The jack is third derivative times omega cubic. So here L over 2 is correct. And pi over beta cubic is correct. And the sine function pi theta over beta is correct. And omega cubic. This equation is also correct. So we copy this to the other shells. So we got all the values, velocity, acceleration, and the drag. I will show you how to use the XY scatter plot to draw the SVAJ diagrams. I move the mouse to the insert tab. We can go to the drawing group, and this is scatter. We have many scatter can choose, but this time I choose scatter with smooth lines and markers, and click it. It shows a black diagram, so we need to add the data into this diagram. We can select this diagram and click the right mouse button. It appears a toolbox and select the data. Add the data. So we need to add data for series S values. So equal sign and select candle tension angle from A26 to A41 and select a range for series Y values. So now we need to show the displacement. So I select D26 to D41 and enter OK. OK again. So I can show the diagram here. I want to modify the format of this diagram. Here, I put harmonic motion. To tell it is what is. And I want to show the label of axis for X and Y. So I come to here and click chart elements and select axis title. So I see the axis title here and here. The X-axis title, I put can rotation angle. In degree. And here, I put displacement in inch. And I want to show the range between 200 10 degrees to 360 degrees. So I select the label and create a right mouse button. We see format axis and click it. So now we have a bounce. Minima is 0 and the maxima is 400. So I change 0 to 210 and 400 to 316. And we can see this diagram is for displacement. I copy this for velocity, for acceleration, and for jerk. And I modify the Y title first. This is a velocity. And in inch per second. And this is acceleration. In inch per second square. And this is jerk. In inch per second cubic. And we change its data. So we select this diagram and click right mouse button to select data. So we need to edit the data. Because now value is displacement, I want to change it to velocity. So I delete here and come to the cell address E26 and we select it to E41 and enter and OK. I get a velocity diagram here. For this acceleration diagram, we select data and edit it. The Y value we change here to here and OK. So we got acceleration diagram and this is for jerk diagram. We click right mouse button and select data to edit this. So we change Y value from G26 to G41. Press OK and OK. Now we get the jerk diagram. So we have a SVAJ diagram now. So I hope you can practice by yourself. See you soon. Bye bye.